All right, class. We're gonna start factoring polynomials in section 5.4 here. So the first thing we're gonna do, factoring. I'm gonna take an example here. We're gonna factor using the GCF. We're finding the GCF and then factoring it out. So in this particular problem, I guess one of the things I would do if it's helpful. Doing, kind of writing and workout, and then, as the more the problems that you do, the better you get at it, and then you can kind of start doing some of this mentally, especially when you have a problem like this, and you're trying to factor out common factors from each term here. So first thing I'm gonna do is just prime factor everything out here. So 2 times A times A times A times B plus 3 times 5 times A times B minus 5 times A. So that's there's B times B. Can't really see that, but B times B right here. So that over a little bit. There we go. So then I guess your goal is to come up with the factors, kind of come up with this circle the common factors they have. So here's one, here's one, here's one. There's a common factor of A, common factor of A, common factor of A. Then they only have one common factor, B and B. So so it happens to be that, what I have circled that's in common, I can't circle another A here because, well, I could here and here, but then over here, there's not another A here. So, it has to be common in all three terms. So, I wouldn't be able to circle this 2 here because the other two terms don't have a 2. I can't circle another A because the other two terms, well, this term does, but this term doesn't. So, you have to be able to circle them, it has to be in all three terms. So then in my final answer here, then I get 5AB, and then whatever's left over is actually is what I write inside my parentheses. So I'm factoring this thing out. So I end up with 2A squared, because A times A is A squared, B plus 3A minus a B squared. Now the funny thing is, notice about this is, if you take this and you distribute it back through here, you're going to get this right up here. This is what you should end up getting. Okay? That's called factoring by using the GCF method. All right? So now here in a second, I'm going to give you an example of, of another type of factor. All right, another type of factoring is called grouping, and this method works sometimes it doesn't work. You have to kind of pick and choose when you use this method. And I'll kind of give you a problem here, an example where it does work. Given a polynomial here with 4 terms, and notice it's in descending order, so that's kind of convenient. And when we group things, that's kind of how you want to have your problem, in descending order. And then that's basically what it is what we're going to do is we're going to group the first 2 terms together, and we're going to group the last 2 terms together. Okay? And then I'm going to take the first 2 terms, and I'm going to basically do what I did before. I'm going to factor out a GCF out of these 2 terms here. So notice I have x times x times x plus 5 times x times x. So ignore this for now over here and just worry about these 2 terms. Well, in this particular situation, I can actually circle x's, which gives me an x squared on the outside. Then what's not circled is on the inside. So that comes out to be x squared times the quantity x plus 5. Now I'm going to go and do this one. So now I ignore everything over here, and I come and do this one. And can prime factor this as, I suppose, negative 1 times 2 times x plus a negative 1 times 2 times 5. Now I can circle the negative 1, the 2. So notice I can factor out a negative 2. And then inside what's not circled is x plus 5. Now for this grouping method to work, notice that my two quantities right here are the same. Okay? That's important. If those don't turn out to be the same, then this obviously wouldn't be able to work. And so what I do to finish up my answer here, or my factoring, is I take this and this, and I make it a factor. X squared minus 2 times x plus 5. And then that's factoring the previous result up here, the previous polynomial. So by rights, if I were to take this and distribute this or multiply this out, I should end up getting what's in black up here in my original example. So that's an example, or a good example, of factoring by grouping. All right, just a couple more examples here. Factoring. So we have a polynomial, and we want to factor it into two binomial factors. Okay. And the previous method using grouping is going to actually help us out with this problem to be able to figure this one out too. Okay. So the rule of thumb here when we do this is to approach a problem like this, especially when it has a leading coefficient like this. Where our goal here is to find two numbers that multiply together to get negative 15, okay, because this number, 3 times negative 5 is negative 15. So I want two numbers that multiply together to get negative 15. But then, let's see, I'll write this closer. Negative 15. But then I also want the same two numbers to add to get negative 2. Okay, the same two numbers add to get negative 2. So, just kind of going through there, well, 3 and 5 come to mind. So if I had negative 5 and 3, that should work, right? So, and I get the negative 2 from right here. I get the negative 15 from multiplying the outside coefficient and my constant. That's how I get these two numbers. So that's how I kind of set it up. And I just fill this in. I use some... use my math, what two numbers to get negative 5 or negative 15, and what same two numbers would add to get negative 2. And again, that'd be negative 5 and 3. So that works. So what I'm going to do with those two numbers, those actually become my two middle terms. So I'm going to take these two numbers and I'm going to make them x terms. So negative 5 plus a 3x, a minus a 5. So you see how these two numbers here become x terms right here. All right, now I go back and I use my grouping strategy like I did previously. Okay, I group the first two terms together and the last two terms together. And I'm using x's here, I'm confusing myself. So here, these are y's. These are y's. So now I ignore this term. I factor out a common factor. Hopefully we can get maybe a little quicker at this and see that the only factor that these two terms have in common is a y. So I factor that y out, I get 3y minus 5, because if I would distribute that through, I'd get this back. Up here, the only thing that I can factor out up here, there's nothing they have in common. So the only thing would be like a 1. Because if I take 1 times 3y, I get 3y. 1 times negative 5, I get negative 5. And I get y plus 1 times 3y minus 5. And I'm done. So I just got done factoring this. Multiplying this out right here should end up giving me this answer right there. Oh, very tricky. It takes a lot of practice to get quick at this, but that is possible. So. All right, let's see if we can't stumble through another one. This one's a little bit trickier, and it uses some properties that we haven't, you know, that I guess they're not necessarily come natural or that are not necessarily remembered, but you know, there's something that you could look up, a factoring property or a factoring pattern. This problem here actually is demonstrated by the first thing that we should recognize is that it's a difference of two perfect squares, and what that factors into is a product of a sum and difference. And so this is something that should just come by you know, recognizing the pattern, I guess. I noticed that 64 is a perfect square. Actually 6x is a perfect square too, because if I take x cubed squared, I get x to the 6th. And then the same thing goes with y to the 6th, so that is also a perfect square. So, and what this factors into is a product of a sum and difference. So notice the exact same terms in each factor here, but then they have a different, you know, they have a sum here and a difference here. So it factors into a sum and difference. Now what's tricky about this is now I can actually continue factoring, because what I have here is a sum of two perfect cubes. And what that becomes is 2, and this is a pattern that we go by, 2 plus xy, 2x plus y times, I think I get 4x squared plus 2xy plus y squared. I think that's what I hear. I'm going to double check. The only thing difference here is that this should be a minus right here. And then the same thing goes for this one, but this is a difference of two cubes. So notice the kind of a little bit of the difference here. I have 2x minus y times, let's see if I do this right, 4x squared plus 2xy plus y squared. Let me make sure that's right. Yeah, and that should be your answer there. So, and again, this actually comes with, you know, practice, and you know, just actually being able to do it a lot. So let me make sure that you guys get that all in there. So that's that comes with a lot of practice. And these right here, actually, the next factors down are not factorable. And I'm just going to give you that much information.